So good evening students. Today we will discuss about CSIR December 2019 Quantum Mechanics Part B solutions. So our first solution reads this. The energy eigenvalues of the particle of mass m confined to a rigid one-dimensional box of width L are n is equal to 1, 2 up to if the walls of the box are moved very slowly towards each other, the rate of change of time dependent energy dE2 by dt of the first excited state. So first of all, we draw our one-dimensional box. So this is our one-dimensional box. So now we know here v is equal to 0, here v is equal to infinity at the walls are infinite. So first excited state is given by E2 is equal to 4 pi square h cut square upon 2ml square. Okay, so the first E2 is given by this. So this is the first excited state. So this is the first excited state. So this is the first excited state. Now we have to do dE2 by dt. Actually what this sum numerical means, that we have to calculate dE2 by dt. Okay, so we should differentiate it. So 4 is constant, pi square is constant, h cut square is constant, 2m is constant, and differentiation of L square, it will become minus 2 upon L cube. Okay, so it become L cube. So now what we can do, we can cut this 2 and write it as 2 into 2 pi square h cut square upon m L square into L. So if you clearly see this, then we can also write this as 2 minus sign upon L, and what we can do, we can write it as 2 pi square h cut square upon ml square. And sorry, we should also write this as using the chain rule. So it will become dL by dt. So if you clearly see this, this is minus 2 upon L E2 dL by dt, which is your answer C. So option C is correct. So option C is correct. Now what we can now this is very easy question of I think 3.5 marks. So you can easily get this question. Now question number 2. So question number 2 reads, two spin half fermions of mass m are confined to move in one-dimensional infinite potential well of width L if the particles are known to be in spin triplet state, the ground state energy of the system. So in my previous video, in identical particles, I have told that the multiplicity is given by 2s plus 1. But now there is some another concept. See, in those questions we have not given any state of the electrons, that it is singlet, doublet, triplet. Only we have our electrons, but in this question it is asking for spin triplet state. The concept is, if now if we have to accommodate electrons, simply say we have to accommodate electrons in this. So what one electron is in up state and one electron is in down state. This is the way to accommodate electrons. Okay, now what is the triplet state? If you have S1 is equal to half and S2 is equal to half, there are two electrons, so you can add them and you will get 1 0. Okay, so 1 corresponds to triplet state, and 0 corresponds to singlet state. So what 0 corresponds to singlet state means, the two states of spin are either it can take value S is equal to 0 or it can take value S is equal to 1. But this now to spin up can't be in one state, if one is in n is equal to 1, then other will be n is equal to 2. So what we can do now if this is n is equal to 1 and this is n is equal to 2. So this is first is n is equal to 1, then n is equal to 2. So in triplet state the accommodation will take place like this. Now see, you are asking that why 2s plus 1 is the multiplicity. So 2 electrons will be accommodated n is equal to 1. No, this is not the case. That is the case of singlet state, s is equal to 0. Electrons can't stay in this. One has to go up. Only the case is they can stay together is if they are in singlet state. So we know the energy of this, we know that is pi square h cut square upon 2 ml square, and this is 4 pi square h cut square upon 2 ml square. So it will become what? 5 pi square h cut square upon 2 ml square. So the answer is D. So correct answer is D. So correct answer is D, right? This one. So now we have to go to our third question. So third question reads like this: a particle of mass m is confined to a box of unit length in one dimension. It is described by the wavelength psi x is equal to under root 8 upon 5 sine pi x 1 plus cos pi x. 0, the width is 1 and 0 outside the interval. This is simply your one dimension 1D box of width 1. Now it is not the width of L. It is given the range is 0 to 1, not 0 to L. So you have to understand this. Now what we will do, first we will write the wave function of this. So what we will get, psi is equal to under root 2 upon 1 sine n pi x upon 1. So this is the case. Now how the expectation value of energy is calculated in the operator form. In operator form you can calculate E is equal to probability of E1 into E1 plus probability of E2 into E2 and probability of N into En, where E1, E2, En are the energy eigenvalues. So first we have to change this. So our given wave function is under root 8 by 5 sine pi x plus under root 8 by 5 1 by 2 sine pi x cos pi x. So what I have to see, I have already told you that the function can't be in multiplication form, it have to be in the sum of the addition. So what we can do this 8 by 5 sine pi x plus under root 8 by 5 1 by 2 sine 2 pi x. That is, we have used the formula 2 sine theta cos theta is equal to sine 2 theta. 2 sine theta cos theta is equal to sine 2 theta. So now this is already changed. Now we have to change in our known wave function. Known wave function. This is the known wave function. So now what we can do, we have to change this under root 8 by 5. I can divide by 1 upon root 2 and root 2 sine pi x plus under root 8 by 5 1 by root 2 1 by 2 root 2 sine 2 pi x. What I have done, I have told you in my previous videos also that you have to change the given function into the known wave function. Known wave function is this: psi is equal to under root 2 upon 1 sine n pi x upon 1. So I have changed it in this form by dividing and multiplying under root 2. So now this wave function we know this. So I can write this. So I can write this as phi 1 plus under root 8 by 5 1 by root 2 1 by 2, and this is phi 2. So now you can check the normalization. Always check normalization. Always check normalization. Always check normalization. Always check normalization. So when we will check normalization, then it will become 8 upon 10. Okay, so now it will become 8 5 to 10 10 4 40. It will become 40. So if you will take LCM, 40 then 32 plus 8, so it will become 40 upon 40. So it is normalized. So wave function So wave function is normalized. So wave function is normalized. Now what we have to do, we have to calculate the expectation value. So now first we have to calculate the so this is, I can point that this is C1 and the whole this is C2. Okay, so now what you can do, you can calculate now easily. E is equal to probability of E1 into E1 plus probability of E2 into E2. So now you can calculate, this will become 8 upon 10 8 upon 10 pi square h cut square upon 2m, because L square is, L is width is 1, so I'll not write anything in L because obviously length is 1. So next is 8 upon 40 into 4 pi square h cut square upon 2m. So now I can take pi square h cut square upon 2m, 8 upon 10 plus 32 upon 8 upon 10, and from here I can take 32 upon 40 upon 40. So it will become pi square h cut square upon 2m. It will become 40, 32 plus 32. So pi square h cut square upon 2m, and it will become 64 upon 40. So when you will so it will become, your answer will be 4 pi square h cut square upon 5m. I think answer is 4 pi square h cut square upon 5m. So the answer will be your B. So this is the answer. So correct answer is B. So correct answer is B. So correct answer is B. So we have completed this question. Always check, always do it. It can also be solved by the help of integration, but it will be very lengthy then, because then you have to calculate the expectation of E, like h is equal to E and E is equal to minus h cut square by 2m curly square by curly x square. But do avoid this method in entrance exams, because you have to solve many questions as possible as. So don't try that method in entrance exam, but you can take as a homework and you can try it with integration method. It will be a good exercise and good practice. So now we will move to question number 4th, I think. Yeah, the 4th. So now it reads, the normalized wave function of a particle in 3 dimension is given by psi x comma y comma z is equal to nz exponential minus alpha x square plus y square plus z square, where alpha is a positive constant and n is normalization constant. If L is the angular momentum operator, the eigenvalues of L square and Lz respectively. So see, this question, if you have to do it, have many methods to do it, but in entrance exams you have to take a shortcut method, otherwise this question will become very lengthy. So the shortest way to do this question is, psi is equal to nz e minus alpha. First I write as it is x square plus y square plus z square. So I know I have to convert this into spherical polar coordinates. Convert to spherical polar coordinate. Spherical polar coordinates. Convert to spherical polar coordinates, and when you will convert, we'll know x is equal to your r sine theta cos phi, y is equal to your r sine theta sine phi, and z equal to r cos theta. So I can write this above as minus, sorry, where I am writing this minus sign, I don't know, n r cos theta e minus alpha, and it will become your r square. Okay, so it will become your r square. Now I have to, from here I can compare it with equation. Compare it with equation y l m theta phi some constant, let it be some constant. Actually it have a value, it have a very lengthy formula, so this constant I will write as a, and in last video I will explain the whole formula. Okay, I think I should write it. Okay, I'm writing full formula. So your formula is 1 minus 1 m so minus 1 m 2l plus 1 upon 4 pi l minus m factorial upon l plus m factorial. Okay, so our PLM cos theta EIM phi, where m is greater than or equal to 0. Where m is greater than or equal to 0, you can okay, so this is the whole formula, but you can treat it as constant. Treat it as constant here. Treat it as constant. So you can write it as a PLM cos theta EIM phi. Okay, so if I'll compare it, I know this cos theta in the Legendre polynomial. Cos theta in Legendre polynomial, cos theta is equal to P1 cos theta. So I can write this as is equal to NR. This is not sub R. This is NR P1 cos theta E minus alpha R square, and I can write this as 0 phi, because e raised to power 0 is 1, so I can compare it with this, and from here value of L is equal to 1. This is the value of L is equal to 1. Actually I can highlight it. This is the value of L, and this is the value of M. So L is equal to 1 and M is equal to 0. So L is equal to 1, M is equal to 0. So now writing the eigenvalues, L square have eigenvalues, L M L is equal to L plus 1 H cut square L ml. L ml. Now Lz is written as L ml. It is given by M L H cut L ml. So from here I can put it the values. These are the eigenvalues. These are the eigenvalues. These are the eigenvalues. So I can get value of L square is equal to 1 plus 1 H cut square, and Lz is equal to ML H cut is equal to 0. So it will get 2 H cut square. So the final answer is, so from here option is C. So option is C. So correct answer is C. So correct answer is C. So correct answer is C. So I have solved all the part B quantum mechanics question. If I have left, then please comment below, and in next video I'll solve section C. Then I'll go to classical mechanics and mathematical physics. So this video is up to here. I hope you enjoyed the video and learned a lot. And in next video we will do some more questions or assignments or previous year. So I hope you enjoyed the video. Thank you very much.